Okay, let's see. In the following exercise, evaluate the indefinite integral with constants equals 0 using substitution. Okay, so let's do that first. 298. The substitution is u equals x squared plus x minus 6. And you can see what's going to happen. Du dx will be 2x plus 1. So if I bring the dx up, I get this, which is literally that piece there. So the integration will become integration of EU du. So that becomes e x squared plus x minus 6, because the integration is just EU, and the c they said is 0. So that answers the first part. Then graph the function and the antiderivative over the indicated interval. If possible, estimate a value of c that would need to be added to the antiderivative to make it equal to the definite integral of this, with a being the left endpoint of the interval. So what on earth are they talking about here? I have no idea, but maybe a graph will inspire me. So it's graph the function and the antiderivative. So graph the original function, 2x plus 1, and then exponential x squared plus x minus 6. Graph. Minus 3 to 2. Okay, and then graph exponential x squared plus x minus 6. So if I see, okay, so this guy here, if you think about it, we want the antiderivative to be this thing integrated at x minus it evaluate at a. So I think basically it amounts to saying c, you want that to equal minus the anti at minus 3 at the first value here. But they ask us to use the graph to estimate it. So let's read that again. Then graph the function and the antiderivative over the indicated interval. If possible, estimate a value of c that would need to be added to the antiderivative to make it equal to the definite integral of that, with a being the left end point of the given interval. What on earth? Why do we have to estimate it? Why just not calculate it? So like integration from minus 3 to 2, minus 3 to 2 of the function. That's going to equal, or not, sorry, x. That's going to equal e x squared plus x minus 6 minus e, what's that, minus 3 squared is 9 minus 3 minus 6. So that's going to equal e x squared plus x minus 6 minus e 0. So like 1. So c equals -1 then. But why -1? How would we get that from the graph? Just seems to make more sense to do it algebraically. Let's do 299 and see what the answer is. So you can use the substitution again. U equals log 2x, and then du equals 1 over x dx. So then you see this here will become the integration of cos u du. So that becomes sine u, sine log 2x. That's the antiderivative. And then we have to graph it and figure out the c. But I still feel like the best thing to do is what I just did a moment ago. It's just c would equal minus sine log 0. I can't really do log 0, can I? Actually, this integration can't exist because you cannot have 0. It's not defined at 0. So that's I think that's wrong. Let's just, I have this open now. So which one is this? 299. Okay, there it is there. The answers. Oh, that's the graph. Is it? No, that's the graph there. Yeah, it goes down. The antiderivative is sine log 2x. Yeah, that's right. Since the antiderivative is not continuous at x equals 0, one cannot find the value of c. Oh, fair enough. They've acknowledged it. Okay. So I'll have to do another question or two to see if I can, if I'm getting the right answer for c. 300. So it's, you can probably see what's happening here. U equals x cubed plus x squared plus x plus 4. So the u dx is 3x squared plus 2x plus 1. So this is going to become the integration of 1 over root u du. So that is the integration of u power minus a half du. Increase the power by 1. Divide by the new power. So that's 2 root that. And then the c would be -2, and the calculation of this at -1. -1 plus 1 -1 plus 4. So cancel, 3. -2 root 3. I hope. Okay, now finally I can get a question where I can actually check the answer. 301. So u equals cos x. So this becomes du dx is minus sine x. So that becomes minus du over u cubed du, which increase the power by 1, divide by the new power. So that becomes -2 over -2. So that's 1 over cos squared x. And the c would be -1 over cos squared minus pi over 3. Too tired to make sure I can get this right. Minus a quarter. All right, let's see. That's the graph. And the c is minus 2. Oh. Oh, why did I do that? Why did I forget about the 2? Okay, so that's correct. Yeah. And sorry, when I type that in on the calculator, I do get, oh, is it minus 2? Did I forget to type the minus? Yeah, no, sorry. I just totally mistyped this in on the calculator. So that's right now. Okay, and that 299, that one was right. Can hope that's right. And 298 as well. I can hope that's right. So is 300, this 302 is basically the same as 298. We could nearly guess the answer for 302. What's different? Oh well, I guess actually it's a tiny bit different. So I better do that on a fresh page then, or not actually, because what I want to maybe do, I didn't. They have the graphs at the back. I should be making the graphs as I go along, but I'm not seeing how the graph is helping me personally. What am I missing here? Let me graph this one here. Let's see what I'm missing. So sine x over cos x cubed. Okay, then the antiderivative, which is 1 over 2, 1 over cos x squared. And it's a 2. I'm sorry. Maybe someone can explain it to me in the comments. I'm really missing what they're trying to have me understand here about using the graph to get the C. Because the C here is minus 2. So like if I just minus 2 off of this, I mean, how am I supposed to tell I'm supposed to go down 2? Is it so that I can kind of see that, like, the areas, like this black area from minus pi over 3, which is about minus 1, that's negative. So I need this, sorry, the red one, it's negative. So I need the black one to go down to be negative, so that, yeah. Like, for example, from minus 1 to 0, the area is going to be equal to this negative amount here, which is, it looks like about 0 minus 0.5 in my opinion. So I just can't see how visually it's supposed to. Maybe there's some trick to it that I'm just not seeing how to figure out the C from the graph. I'm just not seeing it, to be honest. All right, well, I'm going to have a think about it. Maybe I'll be inspired as I sleep on it, how to use the graph to get the C. To me, it just makes sense to use the C as minus the antiderivative at the left endpoint. But anyways, those two are a little bit different, so I'll do them next time. So we're up to 301.